Hello everyone, I am Tahir Galib. In this talk, I'm going to present our research on the long durations of continuous integration builds. Continuous integration or CI automates software builds, which allows developers to integrate their code changes into shared repositories, compile and test the changes on a common infrastructure, and finally get early feedback on their builds. CI starts by developers changing the code, committing such changes to the version control system such as GitHub, and these commits will trigger a build on a CI service like Travis CI. If things go successfully, the software is packaged and deployed to a deployment provider. However, CI builds can take too long to generate, which may impede developers from engaging in other development activities, and can also consume lots of resources and energy. And as a result, developers may decide to remove or skip tests to speed up builds, and sometimes they might stop using CI altogether. Therefore, in our study, we investigate why builds take too long to generate. We start by analyzing how many and how frequent long build durations happen, and then we construct regression models to understand the factors behind long build durations. To do that, we took a public dataset called Travis Torrent that has over 1,000 software projects. Then we select only projects that have a deviation of 10 minutes build durations to end up with 67 projects that suffer from such a problem of long build durations. Using these projects, we studied the proportion and frequency of long build durations. After that, we classified build durations into short and long using three thresholds and collect CI and code metrics and fit everything to mixed effects regression models to explore the important factors associated with long build durations. We find that 40% of builds in our dataset take over half an hour to generate, with an overall median of 20 minutes, and only 16% of the builds in our dataset run in less than the acceptable build duration, which is 10 minutes. We also observed that build durations in most of the projects do not follow a linear trend of increase over time as we think, but rather a fluctuation pattern. We also found that past builds, which actually complete all the build phases, may run faster than failed builds in 25% of the projects. After investigating that, we observed that tests that exceed the time limit and re-executing failed commands multiple times are the causes of this. Our models achieve a high performance in discriminating long build durations with an AUC of 87%. Our models also reveal that in addition to the common wisdom factors such as code size, test density, and number of jobs, CI practices and configurations can also be associated with long build durations. For example, we observed a trade-off between long build durations and developers' attempts to make builds passing. For example, developers may increase the time to wait for long-running commands or tell CI to retry failing commands several times. However, we observed that such practices only gave a 3% reduction of build failures. Another observation is about configuring builds to finish as soon as the required jobs finish, which has shown a high association with finishing builds faster. That means builds are not going to wait for the allow failures jobs, which are usually used as experimental jobs and do not affect the overall build status. However, we found that such a configuration is not being used in 50% of the projects in our dataset. In addition, configuring builds to cache content that do not change often can also speed up builds. For example, when caching dependencies, the CI building machine will install the binaries from original sources and cache them to the CI server so that next time dependencies won't be installed, but rather downloaded from the cache. Our analysis shows that caching is used in 63% of the projects, but only 2/3 of such projects experience a reduction in build durations. And the reason was that caching is actually misconfigured in such projects. Moreover, we found that builds are likely to be slower on weekdays and during the day. And that's because the heavy workload on CI servers. Therefore, we suggest that developers should optimize their tests rather than removing them because there is no such unnecessary tests. And developers should also realize that not all build jobs run in parallel because jobs can run in serial stages. And finally, developers should take into consideration that besides CI workload, CI practices and misuses can also delay the building process. Here is a summary of the key points of our study, and more details can be found in our paper published in MC. Thank you.